Chapter 6, Lesson 2 of Geometry, and I wanted to take this video and do a number of examples where we apply the properties of parallelograms that we discussed in this lesson. And the three properties that we discussed were the fact that if you have a parallelogram, the opposite sides are equal in length. The second property we talked about was the fact that if you have a parallelogram, the opposite angles are equal in measure. And the third property we looked at was the fact that if you draw diagonals in a parallelogram, that they will bisect each other. So we'll take a look at each one of those separately. I'll do some examples applying each of those properties, some that are kind of easy, some a little bit more difficult. And then there is one example that I'll do at the end of the lesson, so make sure you watch that one. You can skip through these as you need. If you watch one or two and feel like you have the concept down, then fast forward and go and look at some examples from the other ones. But make sure you watch the very last example in this video where we look at diagonals of a kite, because I want to show you something that takes place that you'll have to be able to do. Okay, so the first property said that if you have a parallelogram, then the sides that are opposite each other are equal. So a couple of very easy application here. Here we have a parallelogram, so if this side is 13, the opposite side would also be 13. No work to do there. Same thing here. These sides are a parallelogram. It tells us that in the instructions, so the opposite ones would be equal, so that's pretty easy. When we have a variable, again, the property, the relationship allows me to write the equation, so I can write the equation and then solve it. So let's take a look at number 4 here. Again, I know it's a parallelogram because I'm told that in the instructions. I do need to know that first. And because it's a parallelogram, these opposite sides are equal. The instructions say to solve for x. So because these are equal, I can write my geometric equation, which says that FE is equal to GD. That's the geometry. That's the theorem that says opposite sides are equal. I can then substitute in the algebraic expression using the substitution property, and then I apply my properties of algebra to solve. So this would be 2x is equal to 16, so x would be equal to 8. And we can see that we do have the right answer. So fairly simple as we do that. And let's look at some that might be a little bit more challenging. Let's take a look at number 5. I don't know that the algebra is any more challenging other than the fact that it asks us to do something else besides find the measure of x. It says actually to find the length of KL. So once I determine what x is, I'll need to substitute it back in to actually find the length. And again, it's a parallelogram, so the geometry says that the opposite sides KL is equal to the opposite side JM. Once I know that, I can then substitute in the algebraic expressions, substitution property, and then apply my properties of algebra to solve this. Now x is 9. Now again, it asks me to find KL. KL here is equal to x plus 5. So it's actually equal to x plus 5, but now that I know what x is, I can again substitute that in. So KL would be equal to 14. Again, nothing too complicated about this. So I think I'll do one more example and then we'll go and look at the angles. Let's look at number, I don't know, let's look at number, boy, nothing looks overly challenging for you. I'm sure you can do these quite easily. Let's do number 10. So it says find the measure of RQ, which is this side here. Because it's a parallelogram, I know geometrically speaking that SP and RQ are going to be equal. I can then apply, or that's the geometry. I can then substitute in the values or the algebraic expression for each, and then go ahead and solve my expression, so x is equal to 7. Now that I have the value of x, I can use the fact that it says RQ is equal to x plus 2 and substitute in that value of x of 7, so RQ would be equal to 9, so that would be my solution, and again I can check my answer. Alright, so that's the property that says opposite sides in a parallelogram are congruent. Let's take a look at the property where it says that opposite angles in a parallelogram are congruent. The second property that we talked about with parallelograms were that opposite angles are congruent. So do the same thing, do a couple of kind of easy examples, then look at some more difficult ones. Because the opposite angles are congruent, it says find the measurement indicated, so the question mark is what I'm looking for. Now, this actually has to do with what we talked about being consecutive angles. S and T are consecutive angles, and remember we said that consecutive angles, because the parallelograms are formed by parallel lines and transversals, that consecutive angles are same side interior or supplementary. So the the geometry then says that angle S plus angle T is going to equal to 180. Now that I've written the geometry or the algebraic equation from the geometry, I substitute in what I know. So angle S I know is 60 plus angle T would be equal to 180. So angle T is equal to 120 once I apply the algebra to it. All right. So remember, those consecutive angles are supplementary. And again, this is the type of work that I would like to see on your papers. In this example, we want to look at the question mark here. It's opposite the angle that I know, and again, I know from my properties that angle V is going to be equal to angle X because those are opposite angles. I can then substitute in 45 for angle V because I know that. That gives me the angle X, or my measure that I'm looking for. Okay, so let's do one more where we have to work with these supplementary or same or consecutive angles, and then we'll move on to something more difficult. So again, in this example here, we see that the angle that I know and the angle that I'm looking for are consecutive, and because they're consecutive, they are supplementary, same side interior. So angle T again plus angle U is going to be equal to 180. That's the application of the geometry. Substituting in now the algebra, substituting in the 58, and I have this, so then I can go ahead and subtract using, again, algebra. So measure of angle U would be 122. Okay, so just remember those two things, and then if we get to situations where we have variable, it's really no different. We're going to set up the algebra or the geometry the same way and then do the algebra. In this example, let's take number 7 to start with. Now this diagram is kind of tough to see, but we're looking at angle K and angle J here. That's where these two values represent, or these two algebraic expressions. So because these are consecutive, I know that they add up to 180, so the geometry says that angle J plus angle K is going to be equal to 180. Then I can go ahead and use my algebra property of substitution and substitute in. So angle J is 140, angle K is 3x plus 7, and together they add up to 180, so we'll do the algebra now. 140 and 7 is 147, so we add like terms on one side first. Then we'll subtract 147, leaving me 33, so x would be equal to 11. All right, so let's go ahead and look at number 8, and again, simple property, remembering that these opposite angles are congruent, so the geometry says that angle S is going to be equal to angle Q, and now I can go ahead and substitute in the values, or the expressions. Angle 7 is 3x plus 4, and so that's equal to angle Q, which is 2x plus 14. So solving for x, I get x is equal to 10. All right. So let's go ahead and look at these last few down here, last couple down there, a little bit more challenging because there's a diagonal in there. But again, what we want to remember, or as we're looking at these, we have to be careful to remember that there's two angles here that has been divided, they're not necessarily cut in half, so we don't know that they're equal, and together they make up one whole angle of the parallelogram. So remember, this whole angle here of angle D is equal to this whole angle here. Those are what's opposite. And then this whole angle here plus this one here, these are the ones that would be supplementary. So just keep that in mind when you have these diagonals. Now, and don't be tempted to think, well, these are equal because it looks like it's cutting in half, because that's actually not a property of parallelograms. This is not necessarily cut in half. So as we look at this, again, we know that the two properties that we can work with are the fact that opposite angles are congruent and that consecutives are supplementary, so somehow I have to see if I can't apply those. And again, this is 6x plus 16, and this is 4x plus 10, and together it makes up this angle. Now that would be congruent to this, but I don't have any measurement, so that doesn't help me. However, this one, again, with this one, would be supplementary because those are consecutive. So this angle here plus this angle here plus this angle here is going to equal 180 because all of those together make consecutive angles. So angle G, let me see if I can't write this without messing this up. So angle GFD plus angle DFE, and together they make up this angle, plus angle E, and I can do that because there's only one angle here, all together would be 180. And again, these two make up one angle of the parallelogram. This is a consecutive angle to the parallelogram, and together we know that consecutive angles add up to 180. Alright, so it's a little bit more challenging, but still based upon the same property. So now we can substitute in. So GFD is 6x plus 16. Angle DFE is 4x plus 10. And angle E is 64. And together that equals 180. So now we need to find the measure of angle G here. So just let's keep that in mind once we get going here. Oh my goodness. Gosh, we don't even have to do this whole thing, do we? Well, it's been nice that we've had this discussion. I guess maybe I should have looked at the answer first, or the question first, because angle G is here and opposite angles are equal, so I already know that angle G is going to be equal to 64. A good lesson in always remembering, maybe reading the instructions first might make our job just a tad bit easier. Okay, but anyway, seeing how we had that discussion, and that was a good discussion to have, let's go ahead and figure out what the value of x is, seeing as how we have it set up already. So 6x plus 4x is 10x, and then 16 and 10 is, let's see, 26, and 26 and this would be 90. So that's 180. So 10x would be equal to 90. So x would actually be equal to 9. Okay, so that would be x, even though that's not what we were asked to figure out. Okay, let's take a look at number 10. Maybe that. Let's read the instructions first before we take a look at it, though. It says find the measure of KLM. So where's KLM? KLM. So that's this whole angle right here. So I do have to find that together. And again, because we had that discussion earlier, this should help us. KLM is this whole angle here. I don't know what its opposite, so that doesn't help me. But again, I know that this angle, along with this angle together, would be supplementary because they are consecutive angles. The problem is this angle here, KLM, has been split into two parts. One part is 72, the other part is 4x plus 9. So I'm going to need to add those together to get measure of angle KLM. Alright, so geometrically speaking then, angle K plus angle KLJ plus angle MLJ is going to be equal to 180 because those three angles together make up the two consecutive angles of the parallelogram. Then we can substitute in our value. So angle K is 4x plus 11. KLJ is 72, and then MLJ is 4x plus 9 equals 180. So we want to simplify this side first. So I have a 4x and a 4x, which is 8x. I'm just going to kind of cross those out so I know. And then 11 and 9 is 20. 20 and 72 is 92 equals 180. So 8x is going to be equal to, let's see, 88. So x is going to be equal to 11. Now that we know what x is, we can go back and see how that helps us figure out the measure of angle KLM. KLM now is going to have to be made up of this angle here, which is angle KLJ, and I'm going to have to add it to this angle here, which is angle MLJ, and together those will equal angle KLM, which is what I'm looking for. So let's substitute in what we know then. KLJ is 72, MLJ is 4x plus 9, and together that's going to give me KLM. Come on, having trouble writing here. Now I know what x is now 11, so that's going to be substituting 11 in for that, plus 9, so this is 72. 44 and 9 is 53. So together that's going to be 125. So 125 then would be the measure of angle KLM. Alright? So a little bit more work to do on that, but again, remember the two things we use in this lesson, the fact that consecutives are supplementary and that opposites are equal. Alright, let's take a look at a few problems where we have the diagonals, and then don't forget to watch that last problem we're going to do. In this last set of examples then, we'll take a look at the last property of parallelograms that said that the diagonals bisect each other. So remember, bisect means to cut into equal parts. So here we're asked to solve for x, and SW, so that's from here to here, is 14, and WU is 2x plus 14. Now, what's the relationship between those two parts? Well, this is a diagonal, and because this other diagonal is drawn, this is being bisected, so we know then that SW is equal to WU. So that's the geometry. Now we can substitute in what we know. SW is 14, WU is 2x plus 14. So we get 0 is equal to 2x, so x would be equal to 0 divided by 2, or 0, so we have x is equal to 0, and we have the answer here. Let's do one more, and then we'll look at what are considered to be the more difficult ones. Let's take a look at number 4, I guess. That looks like maybe a fun one to do. I really don't know, I'm just looking at it. Let's see if I can, there we go. So number 4 here, VE, which is, let's see, this segment here, and ET they give me. Now these are equal to each other because this diagonal is cutting it in half. So I know that VE is equal to ET. So that's the geometry part of it. Now we can substitute in. So VE is, whoops, that's kind of, didn't want to do that. VE is 3x plus 3. ET is 2x plus 10, and then we solve and we get x is equal to 7. And again, you see what I'm writing on these papers. This is what I would expect for you to see on your homework paper as you're doing your problems. Alright, let's go and look at these last few problems here, and then again, don't forget to watch that last one. In this example here, number 6, it says to find the measure of LJ. LJ is from here to here, okay? So that's this segment. That's where we need to go. Now it says that LJ is 2x minus 9 and JN is x plus 2. So I know these two are equal to each other. So the geometry says that NJ is equal to JL, or LJ. So then we can substitute these values in. Jn is x plus 2, and Lj is 2x minus 9. So solving for x, x would be equal to 11. So now that we have x solved for, I need to figure out the length of Lj. Lj is 2 times x minus 9. So 2 times x, which I now know is 11, minus 9. I don't know why I wrote 2, minus 9, so that's 22 minus 9, which is 13. So you can see that Lj is equal to 13, so that would be my answer. Okay, not any more complicated than what we've been doing further, just an extra step. All right, for one last example before we get to that last one that I want you to watch, let's do number 9. And again, if I look at the information they give me kx as being something, and I know, and then they tell me that km, which is the entire length, is 3x plus 9. Now, this leads to something that's a little bit interesting. I know that kx and xm are equal, but how does that help me with km? Well, if I knew the length of one of these, then I could double it and equals that. Or I do know that kx is equal to xm, but it doesn't tell me anything about xm. So how in the world am I going to do this one? Well, we're going to have to go back to something maybe we've done before, and that is the fact that I know that kx plus xm would be equal to km. That would be segment addition. All right, so if I wrote that out, I know that kx plus xm would be equal to km. Now the problem is I don't know what xm is. However, I do know something about xm. I know that kx and xm are equal, so which means instead of this xm I could substitute in kx. So kx plus kx is going to be equal to km. Now these are kind of what we would say like terms, so I could say that 2 kx's, do this so we know that those aren't variables, would be equal to km. Well, now that I have my equation, I can use this value for kx, I can use this value for km, and I can solve my equation. So I have 2 6x minus 3's equals km, which is 3 plus 9x. And then we can solve. So I have 12x minus 6 is equal to 3 plus 9x. So 3x is equal to 9, so x is equal to 3. Now that's still not the answer to my question because they want me to find km. Well, I can go back and again use the km expression, 3x plus 9 times x, and now substitute in the value that I now know x is, 9 times 3. So that's 27 plus 3, which is 30. So km is equal to 30, which you can see the answer is right there. So again, the more difficult ones just ask you probably to remember something you've done before. So remember segment addition might come in handy, or anything that you've learned previously that you can apply in addition to the new property that we learned, that the diagonals have been cut in half, or those segments are equal to each other. All right, I have one more example that's out of your book that I want to do, so let's take a look at that one. The problem that I want to do out of your book is this one right here, where I have the answers here, where we're asked to find the value of the variables x and y. Now, if we apply the property that we've learned so far, we know that these diagonals are cutting each other in half. So I know that this segment here, which is x plus 8, is equal to this segment here, 2y plus 5. Now, the problem with that is we have an x variable and we have a y variable, so we can't determine the value. So let's take a look at the other two pieces of the other diagonal. Well, in this diagonal, or these pieces of this diagonal, we have the fact that 2x is equal to 3y. And again, we have a situation where we do have a true statement, but one variable x and one variable y. But you remember, whenever I have two equations with the same variables, I can then apply substitution or elimination in order to solve for the variables. And if I'm solving for substitution, or I want to use substitution, I want to use this x here because it has a coefficient of 1, and solve for x. In other words, take this equation and get everything on the other side except for the x. So if I subtract 8 from both sides, I get the fact that x is equal to y minus 3. Now that I know what x is, I can take this 2y minus 3 and substitute it into the other expression for x. That's substitution. And by doing so, I now have an equation where the only variable that I'm working with is the letter y, so now I can solve it. So we'll distribute the 2 here, and then we'll solve for y. So y is equal to 6, which is my correct answer. And now to figure out x, I take this value of y and I put it back into this expression for the y, and that will solve for x. So x is going to be equal to 2 times the y value, which I now know is 6 minus 3, so x is equal to 9, and again you can see that that is the correct value. So remember, when you set up these equations, if you don't have a variable, or if you don't have just one variable in the expression, you can always write a second equation, so applying the same property or a different property using the same variables, and then you have the algebra property or the algebra skill of substitution that you can use to solve that equation for the variables that you're looking for. Okay, so those are the types of problems you'll need to do for your homework, and you'll need to be well versed in order to do well on your quizzes and tests, which I fully expect you'll be able to do. So that'll wrap this up, and we'll see you in class and talk to you on the next video. Or maybe I should just say that's the end.